So, I am Neil Anthony Cubit from BSME 2. This is my assignment 2, and this is my explanation of my programming for solving this assignment 2 in our computer programming subject. So, for the first problem, we're finding here on what is the smallest amount of coins that this fork can produce in a $1.56. So, in the first one, it's quarter, dime, nickel, and penny. So, in a quarter is 0.25, dime is 0.1, nickel is 0.05, and a penny is 0.01. So, total number divided by this 4, or divided by each of these 4. So, here, and here, and here, and here, and here. And we're using print function to show us the result of this, or to show sentence that is being put in this single quote. So for the first one, the total amount of quarters in a $1.56 is 6.24. In a dime, it's 15.6. In a nickel, it's 31.2. In a penny, it's 156. So therefore, the smallest amount of coins is quarters because it's only 6, or 6.24, but it's only 6 if we are indicating for coins. So problem 2, sphere. So sphere, solving for sphere, the volume is 4/3, that multiply it to pi r cubed. And here we're converting SA to radius. So SA divided by 4 pi is, wow, no. It's square root of SA over 4 pi. So we're using import math here to put math or math pi or pi. Because if we use CMath, we cannot directly multiply it here. So S equals 2000 square meter divided, you divide it to 4 pi and squared it, or no, you square root the result here. So for the volume, it's equals to 4/3 math pi multiplied to the radius to cube. So print function again, the volume of the sphere is V. So the volume of the sphere is 8,410.4417. Let's round it up to 4 decimal places. So this is the answer for number 2. 8,410, 44, 4417. So for problem 3, we're solving for a right circular cone. So h is equals height, r equals radius, v equals volume. So in this, we are using a different kind of symbolic package. We're using CMath here. So h equals 6, r equals 5, SR here it's only equals to the r squared. So v equals um, one third SR times height. So the volume of the cone is, we're using here the CMath.pi. So we're multiplying pi into v to find the answer. So the answer is 157.0596. Let's just round it up to 4 decimal places so that it's not hard to read. So problem 4, we're solving for box or open top box. So A, B, C are the dimension of the box. So they're all in centimeters. So we're finding here for cubic meter. So we're converting these 3 into meter. So divide it, all 3 of them, into 100. So after dividing them to 100, you multiply all the three of them to find the volume of the open top box. So using print function again, the volume of the open top box is 3 cubic meter. Still the same as problem 3. So problem 5, we're finding for acceleration here of a car that is initially at rest, then reaching a top speed in 10 seconds, 120 mph. So we're finding for km phr squared. So we're converting here, 120 is the top speed. So we're converting it to kmph, then converting our time 10 seconds to hours. So after that, we're solving for acceleration. So acceleration is the top speed and dividing it to time. So using again print function, the acceleration of the car is 69,511.8790. So using again 4 decimal places. So problem 6, we're solving for free fall of a falling body. So t equals time, a equals acceleration, h equals height, v equals velocity. So we're using formula vf equals vi plus at, and h equals at squared divided by 2. So time here is 8 seconds. So t1 is only the square of 8, and so we're solving for h here. So h equals 8 times t1 divided by 2, and 3 here equals 8 times t. So print the height of the, still using print here, so the height of the building is, and the velocity of the body is. So the height of the building is 313 or 313.92 meters. For the velocity, it's 78.48 meters per second. So this is final answer. And for the last problem, we're solving for limit. So I'm using here SymPy, because SymPy is also a symbolic computing package, same as CMath and Math, and many more. So use here import SymPy as SP, or SP because it's just a shortcut, so that is easy to indicate. So x equals SP, that symbol. So changing x, instead of being a text only, it's being indicated as a symbol or a variable in this function. So f is a function here. So we're solving for x squared minus 25 divided over x minus 5 as it approaches 5. So L here is sp dot limit. So we're solving for limit, that's why we use here sp dot limit. So we put here f, then we put here x, because if we put here x instead of f, it will only show the answer as x only. So let's change it again to its original form. So for the answer, using print function again in the last part, the limit is -5.